Okay, well, let's switch back to that other screen. I'm sorry about that. This camera keeps freezing, and I'm not sure why. We want to find the determinant of this 3x3 matrix. So, switch to my paper. What am I going to do first? Y'all have a trick that y'all added to your bag of tricks from finding a 3x3 determinant. What do I need to do? Okay, recopy the first two columns. 5, 9, -1, 10, 8, 1. And we'll have parentheses minus parentheses. You start multiplying in the upper left-hand corner. 5 times 8 times 0, 0. 10 times 0 times -1, 0. As we said, you should be hoping that you have a whole lot of zeros when you're finding a determinant of this size. 5 times 9 times 1. Okay. And now what do? Okay, now we're still positioned at that 5. We're going to go in the opposite direction. 5 times 8 times -1 is -40. 5 times 0 times 1. 10 times 9 times 0.
Oh, this works nice, doesn't it?
So in the first set of parentheses, we have 45 minus...
The red minus is just from the formula.
And then we have -40 plus 0 plus 0, a -40. 45 minus a -40, what is that going to give me? 85. For my final answer of 85, let me ask you something. Suppose we had zeros. Suppose that 5 had been a 0. What do you think the determinant would have turned out to be? Say you have a whole column of zeros, or even just a whole row of zeros.
I think they can see it better with the column.
Suppose that 5 had been a 0. What would you have as your determinant? If it had been 0, 0, 0, every one of these products would have been 0. And if you take linear algebra, you'll discover that if you have the same row, two rows that are exactly the same, guess what the determinant's going to turn out to be? 0. So there's all sorts of observations
to make this video long.
I know.
3 minutes.
I don't like 3-minute long videos, but we're stuck here because this is where we're going to stop. And Wednesday we're going to pick up with Kramer's rule. Kramer's rule is a method of using determinants to solve linear systems. So you'll have substitution and elimination to solve a linear system, but you'll also have Kramer's rule.
Kramer's rule works really nice because if your answers are going to be fractions,
there's no substituting back in. It gives you the fractional answers.
You don't have to plug in. Imagine if you had a x equals 11 over 12. You have to plug that in to get y. Not with Kramer's rule.
Okay. And we're going to pick up on...
That's going to be on Wednesday,
the 19th.
Wow.
Okay,
so we sort of stalled enough. It's 4 minutes long.
Stop it.
Any questions?
Okay, stop recording.
Okay,